Before the multi-headed attention, I already had covered a previous part of this into my LinkedIn post. But from multi-headed attention, here we go. So what happens is, like we saw previously, the computation of Q, K and V, query, key and value, and what it does and why it is required. So but it is for like only one head, like one attention only computes this. It's just like word representation word per word, but it is not the same. For example, Indian rice dish. Now, for example, one head focuses on rice, but it misses the context of region is Indian. So, what is the idea of multi-head? That instead of one attention, uses multiple attentions in parallel. For example, you might be thinking that, so what my first question was, that it is making each and every one a query, but it is not that. See, it's like ingredients rice, region Indian, like there can be many relationships. So for example, head one, for the one word only, it looks for the ingredient, it looks for the region, like it looks for the context. And food from rice, like what is the context in it. It's like a pattern, it's not making everyone a query. So how it does for Q for every word, key for every word. For example, head one is ingredient focus. Okay, so here dish is taken as an ingredient which is strong, then head two would be a region focus. So it's like that. So over here, for example, for head one, it's not like that each word is taken as a Q, it is taken you whole at a context. So here Q Indian, Q rice, Q dish, it's compared with all of the K. Now what was K? It's a key. So all of the query is compared with all of the keys. So it's all for the head one only, but with a different context. For example, this is the ingredient view, this is the region view. So like this, multiple heads work together. And who decides this? So basically it's like a 12 heads, like design the models. Well, we will see ahead. So q1 into k1, let's a query into q will get a score, then it is converted to softmax, which is like probability of like given it to 100, and then weights into we get it a value, like what is the value, like what does it contains, and then we get an output 1. Then head 2 we get an output 2. So we finally get the each head, it has its own softmax, and we get output 1, output 2, like that. Now this all depends on, for example, this is a vector like query. So how can I get a q value like a query? So query is computed using this matrix kq, kv and kq vector. So it's like that embeddings come from a learned lookup table. Oh, it's for the same. And WQWK are learned transformations that convert those embeddings into extension specific vectors. So what does that mean? As so, let me take up an example over here. This is a general definition. So WQ is a matrix that transforms an embedding into a query vector. So we require a Q at the end, okay? And all we got is a embedding. This is how it actually works. But before that, let's just get into, so it's what I explained is, it's a vocabulary size, like these are some few terms which I want to learn. So vocab size is number of tokens a model knows. So the number of words a model knows. For example, bird has almost like 30,000, then GPT has almost like, I don't remember, but it's more than 70,000 or something. So we have to do the examples. So it's like the number of words, right? The words includes words, punctuation, symbols, like words. For example, this is the vocab for bird, and 50,000 of vocab for GVD. And what is a D model? D model is dimension. Okay, the embedding vector for each token. Like for example, a word rice or word a cat. In how many ways a cat can be resembled, like the number of indexes it have while depicting it. So it's like that. So d is equals to 4. For example, rice is depicted in 4 kinds of embeddings. Okay, so it's like that a rice can be, there is a vector for a rice like a row, and that rice can be 0.1, 0.2, different kinds of embeddings it is represented. So that's what a D model means. and I remember for BERT it is 768. So this is a BERT example. Bigger the T, the more capacity to store meaning. The GPT has up to 12,000, that's why it's like 600 million parameters it has, right? So it's like 50,000 vocabularies plus 50,000 words. It has like the number of rows, and parallelly it has the number of embeddings for the same. So for a particular word it is like 12,000 and 2020 12,288. So it's like 600 million parameters. This is llama 7 billion. Okay, so now we just start like, do we require a q, k, and v? Like q, we what I'm looking for, key and value. So let's just start with wq. What is an embedding? Yeah, you know that. So I don't know why I put this example over here, but it's like photo filter and a new photo. So yeah, the one which I explained, that query, we have query, we got embedding. From embedding we have to create a query. So how does the internal things work? This is all about it. So this is not a real thing, and I mean it is a real thing, but let's just move forward. So here a clean math about it. X into wq, x into wk, where x is equals to n into d underscore model, where x is the collab, vocab words, and d is the dimensions. That makes this embeddings. So that means embeddings into wq. And then we got the formula which we already discussed earlier. Now we take a real example. For example, Indian rice dish. Okay, so now each one has a token of it itself, a token number. Now token number for BERT it is 768. The dimension, vocab size is 30,000, and there are 12 heads. So I remember what are heads, right? So heads are like multi-headed attention. Like each head can take our context and make each and every word a cue, and then search for it and apply softmax onto it and get output. Okay, so this is what it means. Now what is so for example, just a second, here we go. So we have word embeddings and 12 attention heads. Now embedding lookup. So BERT has huge embedding matrix, right? So 30,000 as we saw earlier. Now dish ID is this. This means the embedding of the dish is over this token ID, and it has 768 numbers because that's for the BERTers. Now dish is a one-dimensional 768, like it looks for the row. Okay, there are many rows. There are many 1 2 3 4 rows, and it looks for this dish one row. And in this dish row, it has like 768 columns like this. So this vector contains semantic meaning, contextual tendencies, and learned patterns. So that makes this. There is like 768 features about this. Got it? Now each of this has 12 heads, as I'm taking a example of BERT. Now what happens, like 768 is too much to compute for each head. So what it does, it turns 768 divided by 12, that's 64. So it gives like 12 smaller perspective of the same, right? So what I do is here 760 divided by 12, so just 64. So that's why it becomes like 64 embeddings to look for rather than 768. So it just computes to manage or pick metrics and compute for a little, so that overall the heating cost is reduced. So see, now this is actually a cross multiplication. This is a cross multiplication. So because the embeddings for like the dimension should be same to them to multiply. So input embedding, and we want 1 into 64 for one head. So that WQ must transform itself from 768 to 64. So we have this matrix multiplication rule where we have this, where the columns and rows has to be same to get it multiplied. So WQ is a learned projector. So learned projector is like it has been filtered and then a queue has been done. So 768 to 64, so this is head 1 for it, this is head 2 for it similarly, and what gets embedding of dish into a matrix. Now what is actually this? Embedding is dish means we know about the word dish, but what is WQ? It's a learned transformation matrix. Means how should I convert this to a question for attention? Right, because like it is a general meaning, and embedding, it's a word. The query is like what the word wants to search. It's like that. So word dish, it's food related, it's a noun, or do you want to go into grammar or the place, the region where it belongs to, and that's how we look for ingredients, look for cuisine, look for descriptive context. It's like that. And so in e dish into WQ, and that's where we get a query, the term q. And this is how the same for others, how we get for key and for value, right? And then how the attention starts, and then this is the compute, and whichever we have the highest score, like as I explained earlier, the earlier post for LinkedIn, and that's how we get a QKV matrix. There we go. Thanks for listening, and we'll continue the series on transforms. Bye bye.